Hello, everyone. So welcome to our first lecture of the semester, and we're going to be talking about just an introduction to the Earth, how it formed, how we measure our position on it, and how it orbits around the sun. So first off, I just want to define what physical geography is, so we know what we're specifically studying in this class. So physical geography is the study of place, especially how it relates to Earth, its physical processes, and how they impact humankind. It's a place-centered perspective on the transformation of environments by society and nature at a variety of scales from local to global. So that really points out that we're studying where things are and how they got there, and how they might impact society. And why should we care about geography? It's more important than just making sure that you don't look stupid on Jimmy Kimmel, but it's also important for understanding how societies function, where resources are distributed, and how the landscape might affect us on our daily lives as we experience the processes in our natural world. So within the Earth system, we have what's called environmental spheres. So these are just interconnected groupings of different processes that are occurring on Earth. And so one of those is the hydrosphere, which is all the water on Earth and where it all moves, as well as the biosphere, which is all the living organisms on Earth, the cryosphere, which is all the ice on Earth, the atmosphere, which is all the gas, and the lithosphere, which is all the rock and geologic material that moves around the Earth. And so if we want to talk about how the Earth's processes happen, we have to start from the beginning. So as Carl Sagan said, we are all made from star stuff. And what that means is that every atom that's in you, every atom that's on Earth, originally formed in the center of a star. And so about 4.6 billion years ago, a star collapsed into a supernova. A gigantic explosion sprayed out dust and star material, and that dust eventually, with gravity, consolidated and formed the Milky Way galaxy, and then our solar system. And we now have the 4 rocky planets and 4 gas giants in our solar system. And to put that in perspective, here are the 4 rocky planets, including the Earth, and much further away and much larger are the 4 gas giants, the Jupiter, Saturn, Uranus, and Neptune, which instead of planets like Earth that are mainly made of solid materials are mainly composed of gas. So what is the shape of the Earth? How is it actually rotating? And so the shape of the Earth is not actually a sphere. It's what we call an oblate spheroid, and all that means is that the equatorial diameter, or the line through the center of the Earth that touches the equator, is longer than the polar diameter, the line going through the center of the Earth touching the poles. And that's because of the rotation of the Earth. The Earth is rotating very fast, counterclockwise around the North Pole, and that rotation causes the material of the Earth to move faster at the equators because it's got to move a further distance because it's further from that axis of rotation. And because it's moving faster, it's pulled away from the center of rotation with centripetal force, and so that causes that oblate spheroid. The planet is smushed from the poles. That rotation happens on an axis. So that axis is at a tilt that's 23.5 degrees away from the plane of the orbit of the planet. So that tilt is really important for determining the seasonal effects on planet Earth. So while it might be really fun to think about what if the Earth was flat, knowing that the Earth is round really gives us a lot of insights as to how the Earth functions in our solar system. So the orbit of the Earth is not round either. it's elliptical, which means it's an oval shape. And that ellipse that the Earth travels on as it rotates, as it orbits around the sun, is not perfectly centered either. So that ellipse, the oval, is shifted just a little bit so that at one point the Earth is much closer to the sun that at the other end of the orbit. And so the point in which the Earth is closest to the sun is called the perihelion. That's here, where the Earth is around 91 million miles from the sun. And the point at which the Earth is furthest from the sun is called the aphelion, where the Earth is a little over 94 million miles from the sun. And this causes the Antarctica to actually have colder weather than the Arctic. So the Antarctic winter occurs while the Earth is in aphelion. So that means that not only the seasonal effects that the sun or the Earth's tilt is tilting Antarctica away from the sun is making the Antarctica colder, but also the fact that it's actually further from the sun. So those compounded effects make Antarctica particularly cold. And so the rotation of the Earth and the orbit also determine the solstices. So the solstice is just a point in which the axis of rotation of the Earth is pointing towards or away from the sun. So the summer solstice here is when the North Pole is most pointed towards the sun, at least in the northern hemisphere. And the winter solstice is when the North Pole is facing furthest away from the sun. And so at the summer solstice, the northern hemisphere is receiving the most amount of sunlight. It's facing it more directly. Whereas in the summer solstice, the northern hemisphere is receiving much less sunlight. And so that has a big effect on the length of the day. You can see here the length of the day during the summer solstice. And if you're at the equator, you're going to have a 12-hour day. The sun is below the horizon for half the day and above the horizon for the other half. But as you move further north, you start to have longer and longer days until you reach a point in which the sun no longer crosses below the horizon and you have a 24-hour sun. And so you can see that that would be a 24-hour Sunday. The equinox is the point in between the solstices. So the vernal equinox is during the springtime, March usually, when we're halfway between the winter solstice and the summer solstice. And the equinox in the fall, the autumnal equinox, is when we're halfway between the summer solstice and the winter solstice. So how do we measure where we are on the Earth? So we do that with latitude and longitude. And so you've probably used a GPS coordinates before. So some degree north and some degree west indicate how far you are from the equator and how far you are from the 0 degree longitude. And we call those latitude and longitude lines circles. They're circles that go around the Earth. Great circles are circles that if you were to cut the planet and through that line, you would also hit the center of the planet. So the equator is a great circle, as well as all of the lines of longitude are also great circles. The non-equatorial lines of latitude here are called small circles, because if you were to cut the Earth through them, then they wouldn't go through the center of the Earth. And so latitude is just how far north or south you are from the equator, and they go from 0 degrees at the equator up to 90 degrees at the North Pole and 90 degrees south at the South Pole. Some important lines of latitude to know about are parallels, as we like to call them, are the equator, which is obviously 0, and then the tropics of Cancer and Capricorn. So the Tropic of Capricorn is at 23.5 degrees north, and that's just when the latitude at which during the summer solstice the sun will be directly overhead, because the tilt is equal to the latitude, and so the sun is directly overhead. And then the Arctic Circle and the Antarctic Circle is the point at which during the summer solstice, or the winter solstice for Antarctica, the sun will not dip below the horizon. So above the Arctic Circle, you have some point during the year in which you have at least one 24-hour day. And so some interesting things happen at these parallels. This is a picture taken at the Tropic of Capricorn during the summer solstice. And you can see these parking poles here. The sun is directly overhead, and so they have no shadows whatsoever, and they kind of look fake almost. And you can see here, this is a time lapse taken in the Arctic during the summertime, and the sun never dips below the horizon because the Earth at that point is always pointed towards the sun. So latitude is just how far east or west you are from some arbitrary location, and we've chosen that arbitrary location to be Greenwich, England, the Royal Society there. And so lines of longitude go from 0 degrees to 180 degrees west, or 0 degrees to 180 degrees east. And so unlike lines of longitude that go up to 90, lines of latitude that go up to 90, lines of longitude go up to 180. And that's how we tell the position we are relative to the Earth. And so in summary, we talked about what is physical geography. We talked about how the solar system formed and the shape and rotation of the Earth. We also talked about how that influences when the summer and winter solstices and equinoxes are, as well as we talked about lines of longitude and latitude and how to measure where we are on Earth. All right, I'll talk to you guys next time.